Okay, this is to give you a quick review on subtracting fractions and where we're using borrowing. So if we look at our problem, there's 4 3/8 feet of ribbon at the beginning of the day. During lunch, student council sold 3 7/8 feet of ribbon. How much ribbon did they have left at the end of the day? So left is indicating that we're looking for subtraction. So I'm going to take what I started with, 4 3/8, and they want me to subtract 3 7/8 because I'm looking for how much we have left. So if we look at our picture, I'm going to start with what I have. I have 4 3/8. So in my picture, that means I can shade in 4 holes and my fraction, my part, is broken up into 8ths. So my picture needs to be broken up into 8ths. And it says 3/8, so I'm going to shade in 3 of the 8. They said that during the day they sold 3 7/8, so they sold 3 7/8. So to show that that's gone, I need to X out. So I'm going to start with my 3 holes. So that means this hole's gone, this hole's gone, this hole's gone. Now I need to take away 7/8. The problem is I don't have 7/8 to take. I only have 1, 2, 3/8. So I'm going to have to cut into my hole. How many pieces do I cut it into? Well, our denominator tells us how many in each. So in each, even though we may not see it, this is already cut up. It's just completely filled in. So this is also 8. Now can I take away 7/8? Well, yes, now I can take away 1, 2, 3, 4, 5, 6, 7. And I still have 1, 2, 3, 4. I should have left, we should have 4 are left out of 8 in each. Okay, so let's look at the work to see if it matches. Again, I'm going to start off with what I have. I have 4 3/8, and I sold 3 7/8. We're looking for what's left, so that's subtraction. The first thing I want to look at is my common denominator. Is it the same? Yes. Then I'm going to subtract 3 minus 7. Well, I can't subtract 7 from 3. I don't have enough, so I have to borrow. I'm going to borrow from the whole number. If I borrow 1, the 4 becomes a 3. And what's taking place is the whole number is giving 1 whole over to the fraction side, but it needs to be in fraction form. So I need to find a fraction that equals 1 whole, has a common denominator of 8, so that this denominator stays common. Well, I know if I put the numerator as the same number as the denominator, I know that that equals 1 whole. So what I'm actually getting on this side is 8/8. But in this case, I already had 3/8, so I'm going to just add them up. 8, 9, 10, 11 means now I have 11/8 and subtract 7/8. So all I did was I broke up that piece just like I did right here. Now can I subtract? 11 minus 7, yes. That gives me 4. Denominator stays the same. And go over to your whole numbers, make sure there's nothing left. We have 3, take away 3, that's 0. So my answer is 4/8. But both of my numbers are even, which means I can reduce. If I reduce just by 2, I'd get 2/4, but that's even as well, which tells me that I can actually reduce all the way to a half. So my answer would be that I have a 1/2 foot of ribbon left at the end of lunch. The other way to do this is to convert to decimals because my fractions are so nice. So I started with 4 3/8. Well, 4 3/8, 3/8 as a fraction is a benchmark. I know that that's 375 thousandths. My whole number 4 goes in front. Then I'm going to take my 3 and 7/8. Again, 7/8 is a benchmark. That is decimal 875. Then bring that 3 over because that's a whole number. Now subtract. The nice thing about subtracting decimals is you subtract the same way you always have. Ignore the decimals. 5 minus 5, 0. 7 minus 7, 0. 3 minus 8, can't do that, so I'm going to borrow. 13 minus 8 is 5. 3 minus 3 is 0. Just don't forget to drop down your decimal. Well, I know that 500 thousandths is equal to a half. They are the same. Usually we see this just 5/10ths, but remember 5/10ths, 50 hundredths, 500 thousandths are all the same thing. So my answer, you can either say half or you can say 5/10ths feet of ribbon left. Okay, so you can try the next one if you want to pause the video, try it and see how you do, and then come back. Okay, so you should try this one on your own. We're looking at bought 3 bags of fertilizer, used 1 3/4. How much fertilizer left? Well, that again indicates that we are subtracting. They started with 3. They used 1 3/4. We're looking for how much is left. In our picture, I start with 3. So that means these are all shaded all the way down. We have 3 bags of fertilizer. But what happened was we used 1 3/4. So I can take the 1, that whole bag's gone. The problem is the 3/4, I didn't use quite a whole bag. Well, if I have a denominator of 4, that simply means that these bags are also in the fourths. So I just have to split up the bag, and that's essentially what I did. If you dump a bag of dirt, you're splitting it, and now I can take away the 3/4. So I used 3 of the 4 parts of this bag. What it looks like is I have a whole bag left, and then a part of another, and that's 1 part out of 4 total parts. Okay, so let's try it with our numbers and see how we did. I started with 3 bags, used 1 3/4. So what we're seeing a lot is this is basically meaning 0. And a lot of you are wanting to just bring down the 3/4. But I can't take 3/4 from a 0 right there. There's no fraction to subtract it from, but I have a whole number. Those numbers are not separate. They're together in that it's 1 3/4, not 1 or 3/4. So I'm taking a part of my 3 away. So I've got to borrow because I have to have a fraction here in order to subtract. So I'm going to borrow from 3. That becomes 2. Remember that this is giving me 1 whole, but I need the whole in a fraction form. Fraction has to have a denominator of 4 because we don't want to lose the common denominator or we add more work. Well, I know if I put the same number on top, 4/4 is the same as a whole. And since I did not have a fraction sitting there, I didn't have a part yet, so there was nothing to add to. So now I have 3 bags, but it looks like 2 4/4, it's the same thing. But now I can subtract because now I have a fraction. 4 minus 3 is 1. Denominator stays the same. And go over to your whole numbers. 2 minus 1 is 1, and I have 1 1/4. And that's what we found over here with our picture as well. Now, could I do it in a decimal? Yes. If you have 3 wholes as a decimal, there's my 3 wholes. My decimal is sitting right there. I just don't usually see it. My 1 3/4, well, again, 3/4 is a benchmark. Think quarters. I have 75 cents out of $1. Then put your 1 in front. Now I want to make sure that I'm adding my zeros to make them look the same. Ignore the decimals, subtract. I have to borrow all the way over. 9 minus 7, 2 minus 1, bring down your decimal. 1 and 2/5, those two are the same thing. So either way that will work if you have friendly fraction to decimal conversion. So to answer my question, I have 1 and 1/4 bags of fertilizer left. Okay, one more to practice with. Number 6, you can pause the video, try this one on your own, come back and see how you did. Okay, so you should have tried this one on your own. It says Beaver has a pumpkin that weighs 5 pounds. Opie's pumpkin weighs 3 and 3/12 pounds. How much more does Beaver's pumpkin weigh than Opie's? Okay, so we've got to pay attention to our question and the order in which they're asking. How much more does Beaver's pumpkin? Well, Beaver's pumpkin weighed 5 pounds. Van tells us that we're going to compare or subtract. Opie's was 3 and 3/12 pounds. Okay, so again, look at my picture. We're first going to show what Beaver's, let's see, Beaver has 5 pounds. So we're going to show what he has. That means 1, 2, 3, 4, 5. All of these are colored in. He has 5 full pounds of weight with that pumpkin. And then Opie, his only weighs 3 and 3/12 pounds. Well, if we're going to compare, we're subtracting, and so I am going to take away just to see the difference between the two I'm comparing. So I can start with Opie's with 3. I can take away 3 pounds, but then I have 3/12 and I don't have 12 sitting there. So I need to cut my picture up into 12s. And now I have 12 pieces, and now I can take away 1, 2, 3. So what it looks like we have left is 1 whole pound, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12. So it looks like the difference is going to be 1 and 9/12 pounds heavier. That's what the heavier pumpkin is. Okay, so let's check it with our numbers. If Beaver starts off and his pumpkin is 5 pounds, and then let's get rid of that. And then Opie's is 3 and 3/12. Well, I'm comparing the two, that's subtraction. So first thing I noticed, just like the last problem, I don't have a fraction on top to take away from. I can't just bring down 3/12. I need to borrow, and I need to put a fraction here. Well, that fraction needs to equal 1 whole. It needs to have a common denominator of 12 so that we don't have to change that. So we know that the top number, the numerator, has to be the same. Now I go back, my denominators are common, now I can just subtract. 12 minus 3 is 9. Denominator stays the same. And don't forget your whole numbers. 4 minus 3 is 1. So that matches here with what we thought the difference was between the two. That 5-pound pumpkin is 1 and 9/12 pounds heavier. Could we have done a decimal conversion with this one? Well, we could have, but the 12ths are not as nice and friendly as our benchmark fractions, and we have not done dividing decimals yet, so we're just going to leave that one as a fraction. I only move them to decimals if they're on our benchmark list and they're easy to convert. There's no sense in making it more difficult than we need to. So here I have my answer. I'm just going to write it in my answer column. That what we were looking for is that Beaver's pumpkin weighs 1 and 9/12 pounds more than Opie's.